Well, hi there. Today we continue our discussion on solving systems of equations. And if you can recall from our previous message, the solution to a system of equations is that point where the two lines intersect. It's that intersection point that represents a solution for both lines or both equations. Well, speaking of intersections, I'm positioned here today in the middle of one of the busiest, most famous intersections in the entire world. Do you know what it is? Well, I could tell you, but I mean, if I did, I'd have to have this big countdown, and I don't think I really have the times for all that. But if you know what this intersection is, this famous landmark intersection is, please leave me a comment. I'll love to hear if you can figure out what it is. So today we're going to do a few more examples of working with trying to solve a system of equations. And remember, that idea is we're going to graph each line using what we know about slope-intercept form and look for the point of intersection where those two lines cross. And that point where they cross is going to be the solution. Now, some of the equations that we're going to have to work with today are a little bit different than some of the ones we've done in the past. There's some tricks and things that we have to do to manipulate our equation to get it to work. Also, we're going to see a couple examples where things get a little bit interesting. So make sure you pay close attention to that. Now, like many things we're going to be doing from here, you're going to need some paper and you're going to need some pencil. There's also some resources you can utilize in our section in our Google Classroom where you can access graph paper and graphing calculators. So get your paper and pencil out. You're going to need them, and enjoy. Now we're going to look at some of these examples where we can start to figure out the solution of some systems of equations. And again, remember, we're looking for where the two lines cross, and that will be the solution for the system. Because remember, every point on a line represents an ordered pair that solves each equation. Now here we have two different equations. We have the one in red, y equals x, and we have the one in blue, y equals 2x plus 1. First thing we have to do in each case is identify what is our slope and what is our y-intercept. Now, in our first equation, y equals x, our slope, we have to look at what number is being multiplied by x. In this particular case, it's a 1. As a fraction, we would write that just as 1 over 1. So our slope for this red line is 1 over 1. Our y-intercept, well, y equals mx plus b. What is being added to the x? Well, I don't see anything there. Well, what number can we add to x and not change our value for x? That would be 0. So our y-intercept is going to be 0. Let's go down to our blue line and take a look at what that one looks like. So for our blue line, our slope, the number that's multiplied by the x, is 2, which as a fraction we're going to write as 2 over 1. And our y-intercept is going to be 1, or plus 1. So let's graph our two lines. So starting out with the red one, our y-intercept is 0. So we're going to have our point crosses the y-axis right there at the origin. And our slope is 1 over 1. So from there, we're going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And remember, we can actually continue that pattern if we want to go down by going down 1, left 1. So let's continue that. Down 1, left 1, down 1, left 1, down 1, left 1. And we can see this is what our line is going to look like. This is our line, y equals x. Now let's graph our line, y equals 2x minus 1. So we start at our y-intercept, which is b is equal to 1. So we go to 1. On our x-axis is right there. On our y-axis is right there. And our slope is 2 over 1. It means up 2, right 1, up 2, right 1. But we're going to want some down on the bottom here. We can see that they're going to cross down there. So let's keep using that slope. But remember, we can do this as down 2, left 1. Negative over negative makes a positive. So we go down 2, left 1. Down 2, left 1, down 2, left 1. And we can see, well, I missed, but clearly that point right there is the solution for our system. And that's our point, -1, -1. And if you take that point and plug that x and y into our original equations here, well, -1 clearly is equal to -1. And if I plug in a -1 here, 2 times -1 is -2 plus 1 is -1. It solves both of those equations. All right, on to our next example. So we've got these two different equations. Now, these are a little bit tricky because neither one is actually in slope-intercept form. Remember, slope-intercept form is in that form where y is equal to mx plus b. You're going to need some paper and pencil to be able to do this, so please feel free to do this on your own on some paper and pencil. So we got to get it so that way the y is by itself. Well, looking at our green equation here, clearly the y is not by itself, so we wanted to get the y by itself by adding 2x to both sides. So we add 2x to this side, we add it to both sides, and we're left with y equals 2x plus 5. Now, once we have that written, we can find our slope. It's 2 or 2 over 1. Our y-intercept is 5, and we can graph our line. Here's our y-intercept. Uh-oh. If we try to go up 2 and right 1, we're going to run out of room. So just again, remember, we can always do negative over a negative is the same. So we go down 2, left 1, down 2, left 1, down 2, left 1. And we can see that this, that's our line for that equation right there. Y equals 2x plus 5. And we got that by solving for y in our equation. Now in our other equation, y plus 3 equals 2x, when we go to solve this one, we want to subtract 3 from both sides. And when we do that, we get our equation y equals, these become 0, 2x minus 3. So let's graph this one. Our slope is 2, or 2 over 1. And our y-intercept is -3. So we go to -3 on our y-axis, and our slope is 2 over 1. Well, that means to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, or down 2 and left 1. Now, wait a minute. Now, we graph these two, and we're looking for the point where these two lines cross. Clearly, they don't cross on our graph. But now the question becomes, will they cross? Will they cross somewhere, up off the top or down below? And clearly, it's hard to see because my drawing, I didn't use a ruler, and it's not really well done. But can we tell if, in fact, that these two things are going to cross, or will they never cross? Well, here's a hint. If they go in exactly the same direction, they're called parallel. Now, what would tell us if they go in exactly the same direction? Well, if you recall, it's slope that tells us the steepness and direction of a line. And if you notice, both of these lines have exactly the same slope. They both have exactly the same slope. The slope is 2. And because they have exactly the same slope, and because they cross the y-axis at different points, these two lines are parallel. They'll never cross. So, what solves both of these equations? Nothing. We say that this is no solution. We say that this system has no solution because these lines will never cross. Now, there's not going to be any like this on the homework tonight, so be aware of that. But this is a little bit of enrichment, some things that you should be familiar with. All right, let's do another one. So here we have 2 more equations. Now, this is where it's getting really hardcore. This is where we have to really be good at our algebra and how we work with these things. So this first equation, 4y equals -2x plus 12, we've got to get the y by itself. And we can see that there's a 4 times y. Well, the opposite of multiplying by 4 would be to divide by 4. So I got that. I got to divide that by 4. But that means we also have to divide this whole thing by 4. Well, on our left side, that gives me a y because this 4 over 4 becomes 1. But now we have to divide each of these things by 4. And that's what happens. It's a version of the distributive law that's going on there. Well, -2 divided by 4, 2 over 4 is just 1/2, and it's a negative, so we have a negative 1/2 x, and then 12 divided by 4 is +3. So our equation is y equals -1/2 x plus 3. We know that our slope is -1/2, and we can write it like this or like this. And our y-intercept is 3. So we can graph that. Let's see here. That's going to be, there's our 3. If I go up 1, left 2, up 1, left 2, or down, I'm going to stop right there just because I don't want to mess up my work here. But you can see roughly what that line would look like. All right, let's work on this blue line now and see what that looks like. All right, we want to solve this thing for y. So we want to get the y by itself. And you can see you've got this 0.5x here. So we got to get rid of that. So let's subtract a 0.5x and subtract a 0.5x. That leaves me with y equals -0.5x plus, what's going on? 3. 0.5, 0.5. 0.5 is just another way to write 1/2. Now, we don't want to work with slope with decimals. So if you see a decimal in a slope, make it the fraction, 0.5s or 1/2s. So here we have y equals -1/2 x plus 3. My slope is -1/2. My y-intercept is 3. Wait a minute. This feels oddly familiar. So my y-intercept is 3. My slope is -1/2, down 1, right, up 1. Wait a minute. We see that these two lines are exactly the same thing. Well, if we're looking for points that solve both of these equations, what solves both these equations? Well, it's everything on this line. And how many points are there on this line? There are an infinite number of solutions. So we would say that this has an infinite number of solutions. That handwriting's pretty good, huh? Looks like a 30-year-old got my pen. So there you have it. Hope that explains some things. The big thing is focus on how we solve our equations for y. That's the big thing. We want to look at that and reach out if you have any questions. I see. I was just doing that to see if you were paying attention. Now that I got your attention, just let's take a little quick review of everything that we just discussed. Remember that when you're working with these equations, they're not always going to be in slope-intercept form, in that y equals mx plus b form. But using our algebra skills, we can take our equations and we can solve for y, whether it be dividing by common factors or just moving pieces of the equation to different sides of the equation. So we have it in that form, y equals mx plus b. Other things that we have discussed is this idea of thinking about what would make two lines have no solution. What would make two lines or a system have an infinite number of solutions? What would those equations look like? When you're done with this video, make sure that you look Khan Academy. We have 2 more links there for videos that you're going to want to watch, discuss a couple more examples of how to solve some systems of equations. There's some work to be done in your practice section, and then ultimately there's an assignment in big ideas. Remember, when you do those big ideas assignments, make sure that you go up there and under your name, you click save and submit, so that way it gets turned in and we can actually assess and look at the assignment. Then go back to your Google Classroom and make sure that you mark as done as well. All right, well, from Times Square in New York City, this looks like that just kind of wraps it up. The crossroads of the world. I hope you all have an excellent day. Bye-bye.